Two students spread a rumor to 5 people. Each person who just heard the rumor tells another 5 who have never heard the rumor. Okay, so this one's a little weird because you start off with 2 people, but then you know that the rumor spreads to 5 people thereafter. Okay, so here's where it gets a little strange. All right, so what we've got to do is, let's see, where's that table? There it is. Okay. Just a second. Okay, so we're going to complete the table. All right, so how many people total have they told that know the rumor after the first hour? Well, if 2 people started off with, they told 5, then that means then a total of 7 people actually, after the first hour, know the rumor. Okay? And then after each of those 7 tell 5, that's 35. Of those 35, they tell 5 more. So this keeps going, and we can figure out what 35 times 5 is. Okay, 35 times 5 is 175. And then that times 5 too, they're going to tell. And then you got 875 people. Okay, so after 4 hours, 875 people know. That's how fast information travels if people keep gossiping. So the function, here's where it gets a little strange, because we have a table, but it goes up by 5, so this much we know. Okay, that much we know. It's just the A is not quite as intuitive as it seems. I know we started off with 2 people, but that doesn't help out the model. And so what you've got to do is you have to think, I'm going to plug in a 7 for the Y and a 1 for the hour, because my A is going to be a little bit different. I'm going to have to adjust my model so it fits the situation. So even though our A is not going to make sense as far as people. Okay, so let's go ahead and plug in a 1 for X and a 7 for Y. Okay, and you can see that if I divided both sides by 5, I actually have A equaling 7 over 5. Now it's weird, okay, but that's like 1.4, okay? So 1.4 adjusts my function so that after that first hour I have exactly 7 people, okay? This then is my function. Okay, and we can just leave it as 7 over 5. So when I want to know in the 10th hour how many people know after 10 hours, only 10 hours, if they tell 5 people, I'm going to go ahead and write a fraction bar here. All right, 5, and they're going to be raised to the 10 hours. Looks like we have 13,761,875. It feels like it's, how can the population of Michigan know in 10 hours? Well, if everybody sticks to telling 5 people, that's how quickly it spreads. Okay. Think of the internet, right? All right. So, well, my eyes are getting dry. On which day will at least 200,000? Now, this is going to be similar to what we were doing with the bacteria, right? We want to type in our function here, and I have it already, and I want to know when it equals 200,000. So I'm going to actually go to my table set, find a good place here. I'm going to go to table set, and I'm actually going to start off at 0, and I'm going to go up by 1, okay? So now I'm going to go to my table, and it looks like by the time it's 200,000. It looks like it happens in between 7 and 8. Okay, that's where 200,000 is. That's 100 and some change. That's 500 and some change. So let's go ahead and change my table now to get a little closer. I know it's between 7 and 8, and I'm going to go by 0.1. And I'm going to go ahead and go to second table. And it looks like it happens in between 7.3 and 7.4. Okay. So start at 7.3. Now I'm going to go up by hundredths. Okay. Right in between 7.37 and 7.38. So if I took the average, that's 7.375. So 7.375 hours, and it'll reach 200,000 people. All right. Okay, number 5 at a school function, there was a mountain of 904 cookies. Each person that walks away takes a quarter of the cookies. All right, so it's basically the amount of cookies is depreciating, right? You start off with 904, and you're actually losing a quarter, right? So you're losing 25%. So this is really a simple interest model. If you put 25 here, well, I get it. That's an easy mistake to make, like 0.25. But remember that you're losing 25%, so therefore you're going to have 75% left every time period. And so we got 904, and if we did, well, if that's our model, okay, we want to know after how many, 5 people. So we can actually just type it exactly as we see it. We don't even have to, we know that's 0.75. We'll go 5 hours. Looks like that's about, we're going to round up to 215 cookies. All right. So when t equals 5, it's 215 cookies left. Okay. All right. Now this was interesting. The way that I solved this did not reflect in the answer key. So I am up for debate on what you guys think. I've thought about this quite a bit over the last couple days, and I think that the answer key is wrong. So tell me what you think. We're starting off with 7 feet of licorice, and we're going to cut that in half every hour. Okay, so we're losing 50%. We start off with 7. We lose 50%. So we have 50% every hour. After 5 hours, how much is left? Okay, after 5 hours. Because after 1 hour, I should have 3.5 feet, right? After 2 hours, half of that, 1.25. So on and so forth. If we do that 5 times, all right, in the calculator, I got 5. I got less than a quarter of an inch. I mean, I got like less than a quarter foot, okay? So if I were to multiply that by 12, I've got 2.625 inches. Okay, now it didn't ask for inches, okay? But it just how long is the rope? You could have just kept in feet. So it's that many feet and that many inches, okay? The answer key, however, and you guys just tell me, did you get this? Anybody get 1.661 feet? That made no sense to me. All right, and I'm a math guy. It didn't make a lot of sense. So explain to me how you got that, if you did, and I would love to know because I'm tired of thinking about it. So I'm going to move on with my life. But I want to know if you got it, okay? If that was your answer, because it's very interesting, but I do have to move on. All right, function. We got this. We want to complete the following table and write the equation for the function. Okay, same thing. You know, we've got some points here, and we're trying to, it looks like if I analyze how these change, it looks like they're just doubling. So that's 64, and then 64 times 2 is 128, okay? So now let's think about how this would work. I know that y equals a times, well, actually, I could go backwards, right? If I'm just doubling, why don't I just divide this by 2, and I get 4. So if I forget that, though, if I forget to do that, okay, with 1, and that should be 8. Okay, now I'm solving for a, and so if I did take 8, divide by 2, I get a equals 4. And so your model equals 4, and then you're doubling, so it should look like that. Or if x is t, it doesn't matter. Okay, and that's all that question is asking. All right, that is a extremely typical SAT question. Okay, so now a farm. Where are we at? 9 minutes. Okay, we're gonna do this problem though. And the farm, the initial population is certain by 140. Okay, that's what they wrote in the table. The estimated population growth is 10% per week. So we're gonna find a function that models the population using the weekly percent growth after 9 weeks. Okay, when will it be that? All right, so these are very similar. It's going to be an easy test if so far the problems are making sense. So why don't we actually find that function? We start off at 140, okay, and then we are actually growing by 10%, so that's 1.1, and it's raised to the t or the x, whatever you want to call it, and that's it. That's our model. So we are ready then to just say, all right, y equals, we can go right here and get a table pre-made for us because we know that it's growing by 10%. All right, so let's go back to my table set, start over at 0, and go up by 1. Okay, so this table setup is extremely helpful to use because it allows you to go to where the function wants you to go, okay, or where the question wants you to go. Go to where the function leads you to go. So here's our table, 140. We got 154. Then we got, after 2, it's 169.4, and then 186.34. All right. Okay, after 9 weeks, what is the bug population? Looks like it's 330, so 330.11. So let's just go ahead and, I guess, round down. So 330 bugs. And then after how many weeks will it be 1,000,000? Okay, well, that's going to take a while. So we're going to have to, I'm going to keep going here. It's going to be a while. Okay, it's only 2,000, but I'm looking for 1,077,000. Okay, well, I'm going to go start my table at 100. Okay, now e to the 6th is actually 1,000,000. So it looks like 1,000,007. So 1.77. We're like right there. So it looks like it's going to be between 99 and 100 weeks because e to the 6 means 6 zeros. That's 1,750,000. Okay, so if I go to my table set and I start at 99, and I'm going to go up by tenths. Okay, 1,000,000.77 is 99.1, right? That's where we want it. 1.77 e to the 6th times 10 to the 6th power. So the answer is 99.1 weeks. All right, that's a good problem.